Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera untuk kita semua. Yang terhormat Bapak Muhammad Nasir selaku Ketua STT Bandung beserta jajarannya. Yang terhormat pemateri kita atau narasumber kali ini yaitu Dr. Laurang Mazaik dan moderator kita Bapak Ahmad Rifai selaku Senior Advisor for International Collaboration. Serta yang terhormat Bapak Ibu peserta webinar pada siang ini di hari yang berbahagia. Alhamdulillah, puji syukur kita panjatkan karena berkat rahmatnya kita diberikan kesempatan untuk menimba ilmu bersama-sama dari narasumber yang luar biasa ini. Yang dilakukan secara virtual dan semoga kita tetap sehat selalu. Dalam rangkaian ini kita akan mengikuti acara The Professor Talk Review of Composite Manufacturing. Nah, berikut ini saya bacakan susunan acara. Yang pertama itu pembukaan oleh MC. Saya selaku MC acara ini. Lalu kedua menyanyikan lagu kebangsaan Indonesia. Lalu pembukaan oleh moderator. Selanjutnya adalah tanya jawab lalu penutupan. Memasuki agenda selanjutnya, kita menyanyikan lagu Indonesia Raya, dimohon untuk on kamera dan posisi sempurna. Terima kasih. Selanjutnya acara akan dipimpin oleh moderator kita Bapak Ahmad Rifai. Bapak Ahmad Rifai, apa kabar?
Maaf. Alhamdulillah baik, Bu.
Alhamdulillah.
Belum di-mute tadi masih di-mute.
Iya, nggak apa-apa. Bapak, kita sudah mulai untuk memasuki acara bersama Dr. Laurang. Mangga Bapak dimoderatori oleh Bapak.
Boleh insya Allah. Terima kasih Bu Rika selaku Kaprodi dan MC. Insya Allah saya akan memandu acara ini untuk selanjutnya. Tapi sebelumnya mungkin Pak Ahsani ini Dr. Laurang Mezek nggak ada fotonya ya? Videonya kok menghilang?
Ada Pak di sini Pak.
Oh di saya kok nggak ada ya? Atau
ada Pak?
Ini
saya ada Pak.
Oh iya ada. Oke.
Panggil aja Pak, nanti ada Pak.
Oke.
Ya, Pak.
Oke, saya mulai ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good afternoon, ladies and gentlemen. I would like to welcome you to our program, which is Professor Talk with the topic of review of composite manufacturing in industry. And I would like also to welcome and to thank our honorable speaker, Dr. Laurang Mezek, to to make time in his hectic schedule to share his experiences. And I really appreciate the head of STTB, which is Muhammad Nasser, Mr. Muhammad Nasser, and his team for their effort to make this program happen. And I would like to greet Dr. Laurent. Bonjour, Dr. Laurent.
Good afternoon, everyone. Nice to meet you.
Okay. Okay, now it's okay. Oh, ça va? I cannot hear your voice. Pak Sani nggak ada suara?
It's okay?
Ada Pak. Ada Pak.
Okay.
Okay. Sorry.
Okay, it's okay. Okay. So, ça va?
Ça va bien, merci. Thank you. Nice to meet you, everyone.
Okay. So, Dr. Laurent, how are you today?
Fine. Very fine.
And how about the weather in Thailand?
Hot.
In your hometown?
Always hot. Too hot for me, always.
Because in Bandung, it's rainy, a little bit rainy.
No, raining is not coming yet in Thailand.
Okay. Thank you, Dr. Laurent, for coming. First of all, I would like to introduce you to the participant. Dr. Laurent is my junior. We have graduated from the same university, which is the University Toulouse in France. Yeah? And we work also together in the same project in Malaysia. And Dr. Laurent has a degree, doctoral degree in material science and engineering. And now he is lecturer in Burafa University, Thailand. Yeah. And before that, he worked with me in a research project in Malaysia. And he has many experiences in research and industry, especially in the composite material. Yeah. In France, in Malaysia, and also in Thailand. Yes, Dr. Laurent?
Yes, it's correct.
And in terms of research, his interest is on composite manufacturing, composite simulation, composite inspection, structural optimization, and artificial intelligence. And he has already published more than 20 international journals, and he has until now 3 patents. Yeah. And I think without any further delays, I invite you, Dr. Laurent, please, the floor is yours.
Okay, so I will share my presentation. Is it okay? You can see?
Yeah, it's okay.
Okay, so thank you everyone to be at my presentation of this afternoon. Thank you, Dr. Hamad, to invite me. So it was a pleasure to present Composite and to work with you. So this afternoon, I will make a review of some composite manufacturing used in industry. So I will firstly introduce composite, general introduction, what it is, the typical application you can find in industry, and fiber and matrix used in industry for different applications. And then I will review one by one the main composite manufacturing used in industry and present some of one more advanced. So firstly, a short introduction of composite. So what is the composite and what is the meaning when we talk about composite? So composite is a material non-homogeneous. So it means it's a combination of different material, but the speciality of composite is you combine 2 material A and B, but your composite, you can always see or distinct the component A and B. You don't merge, you assemble 2 different materials. And why we do this? Because most of the time we want to improve the mechanical property, decrease the mass. In industry, mass is money. So it's very important to always decrease the mass of your product, improve the properties, the mechanical property most of the time, but it can be also electrical property or the cost. Composite is not new. It's one of the most famous use of composite in the history is a Mongol bow in 1200 DC. So Mongol already use composite to produce their bow. They use the appropriate material at the appropriate location in the bow to improve the property of the bow. So it's totally not new composite. But in terms of engineering composite, we talk about the most famous composite is the concrete. Concrete is cement plus aggregate, can be crushed rocks, and bar to reinforce concrete. So concrete is a composite. You have also metal matrix composite, MMC. So mainly used is in engine and machining tools. You have also ceramic matrix composite, CMC. It's mainly used in a hot application, so where the temperature is very high. So by example, for the high performance brake for sport car or aircraft, or also in an engine, aerospace engine. And the last family of composite is the reinforced polymer. I will detail now. Reinforced polymer consists of one polymer. Polymer, I will sometime mention matrix, reinforced by different reinforced particles. So these particles can be long fiber, short fiber, or small particles. So you have three types of reinforcement for the matrix. Today, in this presentation, I will present only the manufacturing process for long or continuous fiber. I will focus on this one. FRP, fiber reinforced polymer. You can see on this microscopic observation of fiber reinforced polymer, we have two components. Component A is the fibers, component B is the matrix. So the composite is made by these two components, fiber, matrix, but at the end, you can always see the component A fiber and you can see the matrix. So you can distinguish the two components, okay? What is the advantage of this type of composite, the FRP? It's light compared to metallic material, about 1.7 for the density compared to 7.5 for the steel and 2.7 for aluminum. The ratio strength over modulus is pretty high, higher than for metallic because the density is very low. And one advantage is as you use fiber, you can choose the direction you reinforce. So you can choose the direction you want stiffness. So you can optimize your product. The inconvenience or the drawbacks are it's more expensive than metallic. The manufacturing is very different. So you cannot switch from metallic process to composite process. It's two different worlds. And it's a little bit higher in terms of cost compared to metallic machining, traditional machining. And finally, the quality control of composite is very different because you have two components, fiber and matrix. So to control the quality system are different and the quality process. Applications. So basically, you can find composite in sport product, all the golf, baseball, cricket, surfboard. You can find in transport, automation, bus, subway, train, automotive, sport automotive car. Aerospace use a lot of composite because it's very light and strong. And energy, especially for the wind blades, so for energy production, because it's light. Briefly on composite, the fiber used in FRP, you have the three main fiber are carbon fiber. So carbon fiber have a high mechanical property. So the strength is very high. So it's mainly used in the structural application like aerospace fuselage, aircraft wing, sport automotive frame. So application where you need to save mass and to be very strong. but the cost also is expensive for carbon fiber. In the opposite, you have glass fiber, so really cheaper, with dielectric properties, with excellent chemical and corrosion resistance, but the stiffness, the mechanical property are really lower, really lower than the carbon fiber. So glass fiber cannot be used in structural application like aircraft fuselage. It's not enough strong and it's too heavy, but glass fiber can be used in cheap application. And the last fiber is aramid. So the commercial name is Kevlar. So Kevlar is the commercial name. The product is aramid. So aramid fiber is very good for impact. So it's very tough. So all application where you have impact application and chemical and fatigue resistance is required, aramid fiber is a good candidate. And it's very light, exactly as carbon. But the mechanical property in compression is very low, so the application is very limited. So especially impact, armored bulletproof, security application. In terms of fiber, you can find long fiber or short fiber. So long fiber is mainly used for structural application. So aerospace use only long fiber. And short fiber, as you can see on the left picture, it's a few centimeters of length. This is a glass fiber, white color is a glass fiber. So the mechanical properties are very low. So it's basically is used in a swimming pool. So swimming pool is use short fiber. So application where property is not the key. Something very important in composite, in fiber reinforced composite, is the different scale from the fiber to your final product. So reinforced composite, fiber reinforced composite, the basic element are the filament. So filament, the size is in micrometer. So typically the diameter of the filament is 6 to 10 micrometers. So it's very, very small. Then you combine this filament to obtain a yarn or tow. So this is a product you can buy. So you can buy a yarn like this. It's a commercial product. And mainly it consists of 12 or 24,000 filaments. So this yarn, you can see here, is made by thousands of filaments. Then you combine this filament with a polymer to obtain a ply. So like a sheet of paper, you have yarn, multiple yarn, surrounded by the resin. And this ply, so it's like a sheet of paper, very thin. You assemble many ply to create a laminate because the ply is too soft to make a product. So you need to assemble many ply to obtain a product you can use. And this is called laminate. And your laminate give your structure, a wing by the wing of aircraft, rotor blade, flaps, spoiler for a car. So you see fiber reinforced composite, we start by micrometer filament and step by step we combine until having your structure in terms of meter, in terms of size is in meter, okay? The ply you can buy in the commercially available. You have two types of ply. You have what we call unidirectional or UD. The fiber, so the yarn, are in only one direction. So you have only one direction for all the yarn are in the same direction. And you have another product called woven or fabrics. And for this type of products, you have two directions of fiber. So we call 0-90 degree. So unidirectional is one direction. Woven fabrics is two directions of fiber of yarn. And finally, the ply you can buy, so UD, unidirectional or woven, you have two types of products proposed by the company you can buy to produce your part, your products. You have the first is called Prepreg. Prepreg is the fiber, so in this picture is a carbon fiber with epoxy. So for this product is epoxy already, you have already your polymer with your fiber. So it's prepreg. And at the opposite, you have dry fiber. And as you can see on this picture, you have only the fiber, no resin, okay, no polymer. So prepreg, you have fiber and the polymer, and dry fiber, as the name, dry, it means no resin, no matrix. In terms of matrix, just one slide, you have two big family of matrix, thermoset, thermoplastic. I will not detail more than this. So thermoset, mainly it's epoxy phenolic. For epoxy, they have a very good mechanical property, so it's mainly used in aerospace or automotive. The temperature of manufacturing is pretty low, but the time of manufacturing is pretty long. The storage is a key point. You need to keep at minus 18 degrees for the prepreg. So you need to store your raw material in a freezer, and you cannot, it's not recyclable. So one time you have your product, your part, you cannot redo, you cannot reuse. At the opposite of this, you have thermoplastic, and the first point of thermoplastic is you can reuse thermoplastic. So you can produce your part, and after producing, you can reuse, you reproduce your part 2 times, recyclable, but not many times, 3-4 times. They have a good impact resistance. For manufacturing, the temperature is very high compared to for thermoset, but the curing time is very, very short. But one of the drawbacks of this thermoplastic polymer, it's very expensive today. So the use is limited. So now I will focus on manufacturing process. So before reviewing all the process, I will just give you the key point for the composite reinforced fiber reinforced polymer composite. To manufacture, you need 3 things. You need pressure to avoid porosity in your polymer. So porosity or voids. So as you can see on this microscopic observation, you can see bubble in your polymer. So it's a defect. So if you have this, it's a defect in your part, and your mechanical property will be lower than what you expect. And you need time and temperature to cure your polymer. So the polymer you have is liquid, it's viscous, and you need time and temperature to make a solid. So to illustrate this, I will show you the curing cycle. So curing cycle for polymer is the temperature profile through the time. So here you have the temperature in blue, the blue line, in function of the time. So we have 3 steps. You heat up your product. You hold the temperature at the temperature required by the manufacturer. So in this case, 180 degrees. And then you hold this temperature during few hours, and then you decrease the temperature, you cool down your part, and you obtain finally your product. So why we need to do this? It's because the resin, the polymer or the matrix, this is the same thing. Resin, polymer, matrix is the same thing. The resin at the beginning is viscous. It's like honey. So the viscosity is pretty high. And you need to apply the temperature and time to go through from viscous to rubbery state. So it means you increase the viscosity, and finally to make a solid. So we call glassy. So glassy is the solid. So you need time and temperature to make solid your polymer. So all the manufacturing process in composite need time, temperature, pressure. So I will review 7, if I have time, 7 process. And we will start by the most common process, the hand layup. So I will detail this one, and the other one I will go faster and show you the main point. So hand layup is the most common manufacturing process using 3 different type of temperature and pressure application. Autoclave for 7 to 7 bar pressure. Out of autoclave, it means oven. You just apply temperature at the atmospheric pressure, and press for pressure higher than 3 bar. So hand layup, I divide it into 4 steps. Step 1, you need to prepare your mold. So the mold given the shape of your product. Then you do the layup. It means you apply the plies. Then bagging and curing time. So curing time is the graph I showed you before. So you apply temperature at the right time and at the right duration. So step 1, composite manufacturing. One of the key points, and most of the time, this is one of the main problems when the quality is not good. This is a mold or tool surface quality. So I show you 2 pictures of mold in aluminium or steel, maybe a steel, sorry, it's steel, I think probably steel. So for one is ribs for a wing, aircraft wing, and one is omega reinforced. So this is a typical mold you have. The mold to manufacture must be clean. You must always clean your mold by acetone or another product. You cannot have dust or any contaminant on your mold. So no water, no oil, no dust on the mold. And then after cleaning your mold, you can apply a conditioner or sealer to smooth your surface, in fact, to decrease the roughness of your surface and to improve the next step. So it means to apply the apply of release agent. So what is release agent? Release agent is a product you apply on your tool surface to be sure the resin, the polymer, doesn't stick your mold, because after curing, you need to remove your part from the mold, and to avoid bonding, you apply a release agent. It can be a silicone or it can be a PTFE. Traditional name is Teflon. So on this picture, we have a Teflon film on the mold. So the mold in this case is just a plate. It's a basic shape. So you apply, you clean, you apply your release agent to avoid bonding. Then you apply your plies. Sorry, it's not easy to say. So the plies, in terms when it's a prepreg, they are protected by bakers. So it's a film to protect your ply. So you put your ply on your mold, you remove the bakers, you apply the second ply, you remove the bakers, the third ply, etc., etc. So you build your laminate. You remember, ply and laminate is a combination of many ply. So in this step, you create your laminate. So when you have the number of ply you want, you apply what we call a release film. So a release film is it's a solid film, solid or perforate film. This is to avoid the resin flow. So you want the resin stay with the composite, with the ply, of course, because you want to reinforce your ply. So this film is to avoid the flow of the resin. Then it's optional, but it's better. In aerospace, you need to consolidate your laminate. So it means you have many ply, 3, 4, 5, 10 ply. So you need to consolidate. So you apply a pressure, not a high pressure, just few bar during few minutes, 2, 5 minutes, just to assure a good condition during the compaction. Then you apply a breather. So breather, it's a very thick tissue, porous tissue, and this tissue is made to absorb the resin. In the case you have too much resin, this tissue can absorb the too much resin, in fact. So here is the breather, it's a white tissue, and you apply the valve. The valve, you connect the pump to make the vacuum, so for the pressure. And you need to apply extra breather here at the vacuum area to avoid the resin flow go inside your pump. Okay. After, if the resin go in the pump, you will damage your pump and your production will stop. So you need to protect your valve. And finally, you close everything with a bag. So it's a bagging step. So the bag is sealed with a sealant tape. So as you can see here, the yellow tape. So you close your mold. So in this case, it's a simple plate. You apply your bagging on top of this, and you apply the vacuum here. So as you can see, you have the vacuum input here with a valve. And the last step before curing is a leak step or leak test. So you check you don't have porosity in your process. You don't have, the pressure is well applied. So you apply 1 bar and you check if the pressure is well applied. And if it's okay, now you can apply the curing cycle. So the curing cycle is time, temperature, pressure. So in this picture, I show you only the autoclave. So autoclave is mainly and intensively used in aerospace because the quality is important. So autoclave is a big oven. So as you can see, it can be small, but it can be huge, as on this bottom picture. So you can make a big part. So autoclave, it's a big oven where you can apply until 7 bar. So 7 bar is very traditional in aerospace industry. The interest of autoclave, it's the pressure is very well applied on your surface. So you have a good repartition of the pressure. You have a high quality product using autoclave, and the mechanical property is very high. So the performance, the mechanical property of your part is very, very high. The tools are pretty cheap and light, are pretty, I'd say, yeah? And you can do a large panel of structure type and shape. So it's very flexible to make many type of parts, flaps, spoiler, automotive part. You have many examples like this. The main inconvenience is the autoclave, it's pretty expensive. So it's a big investment. I would like now to jump on another process called resin transfer molding. So what is it? So resin transfer molding, I will say RTM, is you impregnate a reinforcement with polymer. So what is it? You have the shape of your part made with a fiber, carbon fiber, by example, but no resin. So you have your part, you have the shape of the part, no resin, just fiber. Then you impregnate your shape with the fiber. So you impregnate the matrix, and then you cure your part. It means you apply the curing cycle, time, temperature, pressure. So I will show you first the preform, so the shape of your part. So in this process, RTM, the first step, you use the dry fiber. So you remember, I talk about Prepreg dry fiber. In RTM process, you use dry fiber. You can use UD woven, but you can use more advanced fiber, 2.5 3-dimension fiber, and I will show you this after in the another slide. You can stitch the fiber together, the ply and the fabrics together to create a 3D tissue. And most of the time you create this shape in a hot mold before input in the final mold. So just to illustrate, because it's probably not easy to imagine, you can see on this slide on the left the preform. So you have you see it's a spoiler fitting for aircraft, for the flaps. This is the system for the rotation of the flaps of aircraft. You see, you have the shape of the part, but it's only fiber. There is no resin yet. So you create your part made of fiber, but with no resin. And then you apply the RTM process to apply your resin through your shape, okay? So when I talk about preform is this, shape of the part, but only resin, no matrix, no resin. So you create your part, and then you need to apply the matrix, the resin. So you have three technologies, three types of application: closed mold, liquid resin infusion, and resin film infusion. So I will detail one by one. And I will show you some video to illustrate the process. So closed mold, this is the drawing of the process. So in green, you have the mold. So you have the bottom mold and the top mold, lower, upper mold. Inside the mold, you have your ply, so the preform, so the fiber, your part. But you have on one extremity, you have the container with the resin you want to apply. And at another extremity, you have a pump. And with the pump, you create a vacuum and you pull the resin through the fiber. So I will show you a video to illustrate, to show you how it works in the really. Okay, so I will show you the video. I will just skip the beginning because it's not the beginning is not important. Okay. So let's start. So they apply the release agent first. They apply, oh, sorry. I will do and I will stop here. So as you can see, this man carry in his hand the fiber. So this is the fiber, but no resin yet, just fiber. This is the preform. Okay? So they will install the preform in the mold. Okay, so as you can see, it's a small boat. You see, I think it's for the school. They cut, if they have too much fiber, so they cut. So you have already the shape of the boat made by fiber. Let him cut. Okay. They close the mold. So you remember I said upper, lower mold. So this is the upper side of the mold. So they close the mold of the boat. Vacuum. So the pump is connected at one extremity to create the vacuum. And they test. So this is a leak test. I mentioned leak test before. So they check if the pressure is well applied everywhere. And now they will connect the resin injection. And you see the resin up. The vacuum pulls the resin through the fiber. So you see the color? with a glass fiber, it's easy to look. So we have the fiber, the resin, sorry, move through the shape of this boat. For the small shape like this, you have only one resin injection. So the resin is only on one point. For a very large part, you can imagine hundreds of resin point injection input. Okay. Okay, so you can see the resin, the flow of resin move. Okay. Okay, and finish after. So you can see like this the process. And I give you some example of parts. So in this slide, you can see a wing spar for aircraft made by RTM. So you can see the shape, it's very complex. So you see, you have different thickness, a lot of curve, lot of shape. So you can create very high complex part. The advantage of this process is the quality of the surface is pretty good. You control the geometry, the thickness of your part is well controlled. And you can integrate function in your preform. So when you create the preform, the shape with the fiber, before the resin, you can already install some function if you want. So metallic, if you want some metallic part to reinforce some place, you can already input your reinforcement. But the inconvenience are the molds are pretty expensive, especially, by example, for the spar, the molds are complex to do. It must be carefully designed. So the design of the mold and the development of the mold is it's pretty complex. And in terms of volume, you are limited in terms of size. The second process, I will go faster because the idea is exactly the same. Liquid resin infusion, same thing, is exactly the same as before. The only difference is the resin follows the surface of the lower mold first, go through the surface, and then go through the thickness. So in two steps. Okay? First, follow the surface and then through the thickness. But this is the same idea as before. The advantage of this design is you can do bigger parts. But it's more difficult to control the quality. So the previous process, you obtain a better quality part. This one, it's more advanced. And the last one for RTM is a resin film infusion. So as you can see, it's like autoclave. You find exactly the same thing. Green color, you have the mold, release agent. You have apply resin film, and you have then dry preform. So you have the fiber with no resin. So you, in the process, it's exactly as the hand process I show you, hand layup, except the first step is you put a resin film and then you put your fiber, the dry fiber. And then you have release film, breather, bagging, and you apply the pressure as before. By applying the pressure, the resin in the film goes through the thickness. The advantage of this last process, but as you can see, the tools are very simple. So the cost of the tool is really lower than the two other. You can do a very large part, depending on your autoclave size. But the problem is you need an autoclave. And if you have an autoclave, Prepreg as before is certainly better. So for RTM, it will be this will conclude the RTM process. Just to show you, RTM, they can do 60 blade, so wind blade for wind energy, 60 meter the length, 5 ton of resin injection. So RTM, you can do a very huge part. Okay. Now I would like to go on some more specific process, very specific for some application. And I will detail each of one briefly, giving you the principle, advantage, inconvenience, and each time I will show you a video to illustrate. So pultrusion is a process to produce beam. Like at this picture, you produce beam. So the concept is the following. So one, you have the reinforcement, you have the fiber, and you have the fiber, this is the yarn. You remember the yarn filament? You combine filament to obtain the yarn. So one yarn is 20,000 of filament. So in one, you have the yarn. You pull the yarn through the die, so you give the shape of your beam. You heat, so this is a curing cycle. If you heat, this is a curing cycle. Then you have the pulling system to pull the fiber. And finally, you have the cutting operation. You cut your beam. So I will show you a video to illustrate this process. Each time I give you the link on YouTube. So pultrusion, how it works. So pultrusion, it's a 3D video. Huh? So it's a production line. So as you can see, we have the yarn. So this is a bobbin of yarn. In this case, it's a carbon yarn. The carbon yarn are pulling. Yarn go through the resin, the polymer. So you obtain the yarn with the polymer. The yarn goes through the die, given the shape you want. So in this case, it's a simple circular shape. So you do in many steps. The shape you do in many steps. It's not in one step. Then temperature and time. So this is a curing cycle. Time, temperature. So the fiber goes through the curing, the oven. Of course, the temperature and the time is calibrate, matching the curing cycle. Then you have the pulling system. So this is a system pulling your beam. And finally, you cut. You cut the section you want, okay? And you obtain hundreds of kilometers of beam, okay? So this process for composite is very interesting because as you can see on the video, you can produce with a high manufacturing rate. So it's a continuous process. You produce, you can do the shape you want. As you can see on this picture, the shape, the beam shape. So you can create very complex shape, cross section, okay? And the mechanical property of this type of composite is very high because you pull the fiber. So the fiber, the orientation of fiber is perfect. So it's very impressive in terms of mechanical property. But the inconvenience of this production is you produce beam continuously, so you cannot change the shape through the length. So you must create always the same shape. Okay, you cannot reduce the section and increase. So it's always the same section. Okay, and this process is made for the high quantity in terms of length. So typically more than 100 kilometers. So in terms of business, you must produce hundreds of kilometers of beam to make money. And the last inconvenient is the thickness. So the thickness of the section must be pretty high, so higher than 1 millimeter typically. So you cannot do something very thin. Okay. One picture of application. So this is it's in thermoplastic. Never mind. It's a rail fixation. So used in aircraft. So it's a fixation beam along the fuselage in the cabin. So it's very long. It's made by pultrusion. So the shape, the section here, the beam, is made by pultrusion because the shape is always the same shape, the same section. So the process is matched with this application. I talk about 2.5 3-dimension composite before, and I would like to introduce you what is it. So composite, as I show you, it's made by ply. So you have ply like a sheet of paper. So you have no fiber through the thickness. So you have just fiber in the plane. So 2.5 3-dimension composite is a process to have fibers through the thickness. So you have many technology to do this. I will not review everything. So it comes from textile technology. And for our interest, we focus on the 3-dimension. So you have different technology: weaving, braiding, stitching, knitting. So it's a textile technology. And I will show you just quickly some of them. And the first is stitching. So stitching technology, what is it? You had continuous fiber on top and bottom surface of your ply, and you lock these two fibers together. You can lock with different pattern following this picture to reinforce through the thickness. So I will show you. I think I will show you. So this is typical machine use. So it's pretty complex. It's not the knitting for clothes. It's for composite, so it's more complex. But you can see here the picture, the shape. You can make big or small part. As you can see, no resin. It's a fiber only, dry fiber. It means the process is RTM. And I will show you a video to illustrate. So we have different ply. You see, I don't know how many ply, maybe 5, 6 ply of carbon. And they had fibers through the thickness of all the ply to reinforce. So it's a knitting process, textile process. And they can go faster, so they go slowly. So it's a textile process to reinforce through the thickness. Okay? Stitching, the advantage of this process is pretty cheap. In fact, it's a textile technology, and you reinforce through the thickness your composite. So you reinforce, so you improve the toughness of your composite. But you can also, this is the drawback, lost some strength of your composite in the plane. So you need to balance in function of your property.
Dr. Mazek, I would
Yes?
like to remind you, you have only 5 minutes left.
5 minutes? Okay, it's okay.
Please.
So for the 5 last minutes, I will just show you very quickly the last process, braiding. So braiding is very complex. It's very difficult to explain. So I will show you the video, only the video, because it's very, very strange. So braiding, what is it? It's this technology. So you have the mold. So the mold here, it's the beam. And you, I don't know how to say, you apply fiber, the yarn, many yarn, as you can see, through your shape. You see, the process never stops. So the process is made for the fiber are always one top, one down, one top, one down. And you can create, you see, it's pretty fast. Huh? In a few seconds, you can do 1 meter of composite. And the robot will move up, never stop. And you can create like this a long profile and complex profile. So pultrusion, before you can do very many kilometers, hundreds of kilometers, but always the same profile. Braiding, you create the profile you want. You can change the profile during the process. So it's hypnotic. It's very beautiful to see. You cannot see the fiber finally. It's too fast. As you can see, no resin, dry fiber. This is a dry yarn. So you need to use RTM process after. So you see, it's very beautiful. The front of fiber move continuously. Okay. The advantage of this process, it's very fast. You don't lose material. You apply the fiber you need. So you don't have scrap material. You can go pretty fast. You can create the shape you want and change the shape during the process. So it's flexible. I will skip some process. I will skip some process because the time is short. And I will go on fiber placement. So it's used in aerospace. So it's a technology, it's a robot technology to automate the production of composite. So you have two technology, but this is the same idea. What is it? Fiber placement is a robot, and the robot applies the fiber following the shape you want. So in this case, it's a fuselage. You see the fuselage with I think this is the window, the aircraft window location here. So, and I will show you a movie to explain this. Movie is better. I will accelerate. So this is typical application. You have the robot here, and the robot apply the fiber. So you see, this is the fiber with the resin already. So you have the fiber, you have the resin, and the robot applies the pressure. You need pressure to do composite. So the robot apply pressure and temperature. So you can do the shape you want, even complex. You see, we see the temperature with the light, and they will show you, they will zoom. And we can see, okay, the temperature, and we can see, you can see, I want you to show the roller to apply the pressure. You need to apply pressure always in composite. So this is used Prepreg. It's a Prepreg technology. So it's used for the high standard part, mainly aerospace. And I don't know what time I have, how long I have.
Usually it's finished.
Okay, perfect. Okay, thank you very much.
Okay, thank you very much, Dr. Laurent. Dr. Mezek, I think it's very, very interesting for us to attend your lecture. Yeah? I think next time we'll come again and you will finish your presentation. Yeah,
I will do another one. With pleasure.
Okay. So I think there is so many questions from the participant. and in their mind. I think we have already 3 questions. You can look on the chat.
Where is the chat?
I think that you can directly respond to this question.
I need to find. Sorry, huh? Where is the chat?
In the bottom of your Zoom.
Okay.
You have chat.
Where's chat? I will stop sharing. Okay.
Yeah, stop sharing.
Okay, chat. Where is the chat? I'm sorry, huh? Chat. Yeah, 12 question. Okay. Okay, the pressure. So for the pressure, you have different type of pressure for the first question. So the pressure using air. So you can use air pump. You can use press. So mechanical pressure with the press. So you have 2 type of pressure. It can be the pump or the mechanical pressure. So for the curing cycle, tight inspection when which manufacturing which yes.
The second question
is for
question.
For the curing cycle, tight inspection, efficiency, quality management, composite. The composite manufacturing process. So for the quality, it depends on your process, of course. Depending also the industry you work. If you work for aerospace, automotive, or sport industry, the quality process and manufacturing process are very different. So, by example, for aerospace, when you manufacture your composite during curing cycle, you must have sensor on your mold. So you must control the temperature at different location during all the process, because you must control the temperature. So you need sensor, thermocouple on your mold for the aerospace industry. If you want to be sure, you need to control. And you need to control the temperature of the mold, not the temperature of the autoclave or the oven. This is the temperature of the mold, the most important. So if you want to control the temperature of the mold. In terms of temperature, it depends on the resin, of course, of the polymer. Most of the time it's epoxy, so it's 120, 180 degrees, the range, the common range for thermoset.
Dr. Laurent, can I suggest you? Because the question is about the quality management.
Quality management?
Yes, quality management relate to the cost. I think how we can manage the quality for composite manufacturing.
I think it's pretty far from my skill, so I think I will not be the best lecturer for this, because the quality management is not my part. It's very difficult. I think it's pretty far from my skills. Sorry.
Yeah, but I think in aerospace industry, for example, the quality management, there is a standard, some standard.
Yes.
I think
ISO
standard.
There is standard.
So we have to follow the ISO standard for the quality management. And I think this quality management is quite expensive. Yes, this is
yes. It's very expensive. So yes, you have many standards, and the cost of standard is very expensive. And after you have to just follow the standard you apply. Yes. So range of autoclave. Autoclave, it's a big oven, like oven you have, but you can apply a pressure inside your oven. So the autoclave, the only difference with oven is you apply pressure in your oven. So that's why the autoclave look very strong and tough, because it's you need to support high pressure.
The question is about what is the range of the temperature, the best for the best range of the temperature for the best result?
So the best range of temperature. So when you buy the the polymer, the resin, the best thing is follow the data sheet. Follow the data sheet the company give you. If company give you 120 degrees, you follow the process they give you. This is the best way. So for epoxy, typically is 120, 180 degrees. I cannot answer through the chat. I'm sorry.
Okay, last question. If the prepreg after use?
Is the prepreg after use? What is the prepreg can take back to the storage? How long the prepreg? Okay, so prepreg, you have already the fiber and the resin. Most of the time is epoxy. The prepreg must be stored at minus 18 degrees Celsius, and the life in the storage is 1 year. So in aerospace, after 1 year storage in the freezer, you cannot use again. Okay. Outside the autoclave, outside the freezer, so at the room temperature, it must stay just a few hours. You cannot stay one night outside. So just only few hours. So you take off the prepreg from autoclave, you cut your fiber, and then you restore in the autoclave. No, inside the freezer. Sorry. So okay. How long consists in normal temperature? It cannot stay outside. It cannot. Avoid. Just for cutting. Especially in Asia, Indonesia, Thailand, Malaysia. It's a very hot country, so don't store outside.
Okay. Maybe any other question? We have still some time.
Natural composite. It's a very good question. Yes. It's a very good question and a very good point. I just show mainly carbon fiber, glass fiber, so technical fiber. But it's true in Asia, you have lot of possibility to use I don't know. Sorry for my English. It's a French natural fiber like bamboo fiber, coconut. It's a big challenge because the process is difficult. And the raw material, for natural fibers, the key point is the input fiber. You need to collect the fiber, and it's not a technical, it's not a product. So each time you buy natural fiber, it's different. So you need to dry your fiber. So before do your composite, you need to pre-work. You need to clean your fiber. So you must have another step before do your composite to clean your fiber, dry your fiber. But it can be used for many applications. And I think for sport industry, I think it's a very good opportunity to use natural fiber. And I think Asia, especially Indonesia, Thailand, Malaysia, I think there are a lot of opportunity for young engineers to propose new products, green products, especially now in the 21st century. And so we talk about fiber, but we talk about also the resin. Now we start to see bioresin from palm oil. They start to propose natural resin, so to produce a green composite. Not for aerospace, sure, but for sport industry, I think it's the future, definitively for the green industry.
Okay, thank you, Mr. Laurent.
Thank you.
I think it's very interesting. Yeah. And on behalf of the Sekolah Tinggi Teknologi Bandung, I would like to thank you very, very much to you to share with us your experiences. Thank you.
Thank you very much.
Yes.
Thank you again to invite me, and I would like to thank all the participants and all the staff and the head of your institution of technology, Bandung. Thank you very much again.
We have today about 200 participants.
Good. Thank you.
Okay.
Okay.
Okay, I think the time is limited, so
okay. I will
give back the floor to Miss Rika and Adriati.
Okay. Thank you. Thank you again. Bye.
Okay, thank you. Terima kasih. Alhamdulillah. Setelah banyak ilmu yang kita dapatkan hari ini dari Dr. Loreng dari Burapa University serta moderator. Terima kasih Bapak Ahmad Rifai dan peserta yang sudah mengikuti acara dari awal sampai akhir. Jangan lupa juga untuk partisipan untuk mengisi link presensi yang ada di room chat. Untuk hari ini kita cukupkan. Terima kasih Bapak, terima kasih Dr. Loreng. Kita foto bersama dulu ya Bapak.
Loreng udah nggak ada ya?
Oh udah aktif ya Pak?
Saya lupa dia suruh tunggu. Atau mau dipanggil lagi? Sebentar saya panggil lagi kalau.
Boleh Bapak.
Silakan sambil ngobrol-ngobrol dulu mungkin.
Oke, ini material banget. Oh ini ada Pak Abdul Fattah. Assalamualaikum Pak Abdul. Oh, siapkan pose terbaik kalian nih.
Lorangnya nggak jawab lagi, tidak jawab nih Bu.
Apa-apa yang ada di room aja Pak?
Yang ada aja ya?
Iya.
Ini nggak jawab dia.
Oke, untuk di-on-kan kameranya.
Halo Lorang. Tu peux entrer encore un petit peu parce qu'on prend de photos. Pourquoi tu pars directement? Oui, tu connais qu'on prend le photo un petit peu, hein? Ok. Dia datang lagi katanya. Tapi kalau mau foto dulu yang page yang lainnya?
Boleh Bapak. Kita mulai. Oke. Siap ya, sudah hadir sepertinya nih dokternya, Dr. Loreng. Oke.
Udah datang ya, Dr. Loreng?
Ya, sudah. Slide pertama, siapkan senyum terbaik. 1, 2, 3. Oke, slide berikutnya. 1, 2, 3. Oke, cukup Bapak?
Cukup. Oke, terima kasih.
Thank you, Dr. Loreng.
Thank you. Sorry.
Untuk para peserta silakan yang belum dan yang sudah boleh meninggalkan room.
Oke.
Besok jangan lupa kita masih ada ya. Terima kasih Pak Ahmad Rifai.
Ya, sama-sama. Merci Laurent. Laurent, tu peux quitter maintenant.
Thank you Dr. Laurent. Thank you Mr. Ahmad Rifai.